Here we're given an identity and we're asked to prove it. That means we need to start with what we're given on the left-hand side and show that this is equal or equivalent to what we have on the right-hand side. So it's not an equation, you can't move things from one side to the other, but you can show that this is equivalent to that. So you can start with the definition of cotan and tan. So cotan is 1 over tan, isn't it? So cotan is 1 over tan. And tan is sine over cosine. So 1 over tan will be cosine over sine. And tan is sine over cosine. So that's your first step. You rewrite your cotan and your tan. Now you have a problem of combining these together, because here we don't have any addition or subtraction. So how do you subtract or add fractions? You need a common denominator. So the common denominator will have the lowest common multiple of these two. So we're going to have the product of these two in the denominator. And you'd need, therefore, to multiply this by cosine, and you need to multiply this by sine. So you want a common denominator. So the common denominator will be the product, and cosine times cosine is cosine squared, and sine times sine is sine squared. So now we need somehow to get from here to here. Now cosine squared plus sine squared would be equal to 1, but this is minus. So this is actually a double angle formula. And if that doesn't immediately jump out to you, you need to think back about cosine of the sum of two angles. So if you've got cosine A plus B, this identity is given to you in the exam. Cosine A plus B is the cosine of the first multiplied by the cosine of the second minus the sine of the first multiplied by the sine of the second. And if A and B are the same, so if you have A plus A, then you'd have cosine 2A, and that's why we call it the double angle formulas, because 2A, that's double the angle, or double A. So cosine A times cosine A will give you cosine squared, and sine A times sine A will give you sine squared. So here we have an identity. That cosine 2A is cosine squared minus sine squared. So whenever we see cosine squared minus sine squared, we can replace that with cosine 2A. So let's put that in a box. That is going to be replaced with cosine 2A. Okay, so that's your numerator. It just happens that this also looks very similar to a double angle formula involving sine, because if you have the sine of the sum of two angles, A plus B, then that identity, this again is given to you in the exam, is sine of the first times cosine of the second plus cosine of the first times sine of the second. And if A and B are the same, so if it's A plus A, you'd have sine 2A, and this would be sine A cosine A plus cosine A sine A, and because they're the same, you'll have that. So if you divide both sides by 2, we have a new identity that says sine A cosine A is half sine 2A, so a double angle formula. And again, we can look at this denominator and say that is going to be, well, that is going to be replaced with that. So there we have our denominator. So you've got cosine 2 theta in the numerator, sine 2 theta in the denominator. Then you've got a half in the denominator. So when you divide by a half, it's like multiplying by the reciprocal of a half. So if you flip that, the reciprocal of 1 over 2 is 2 over 1. So that's just equal to 2. So that explains that why when you divide by half, you simply get 2. Now, cosine divided by sine is cotan. It's the definition of cotan. Cotan is 1 over tan, or cosine divided by sine. So it's cotan 2 theta. So 1 over half is 2. Cosine over sine is cotan 2 theta, cotan, and the angle is 2 theta. And there's nothing more you can do to simplify, but it just happens that this is exactly what we were asked to find. So the left-hand side is equal to the right-hand side, and that's how you would prove an identity like this. So you're using the double angle formulas to replace these two expressions.